Thank you for joining. My name is Samuel Barlas. Here we talk about networking and cybersecurity. First of all, I just want to let you know that any opinions expressed in this video are my own, do not necessarily reflect the opinions of any past, present, or future employers. So today I really want to talk about DAC cables and some SFPs, and I want to show you a few things here. So I'm just going to jump in and talk about SFPs first because that's what I've got here on hand. So you can't really see this very well, but this is a 1 gig copper transceiver. So you'll see that it is an SFP form factor, that small form factor pluggable. And you'll see there's a little doohickey here. We can keep it in place by having that locked. It'll keep it in the SFP port, and we'll pop it out to go pull it out. But this will just fit your typical Cat5, Cat6 cable, and will be used that way. These do come in 10 gig variants, and you can use relatively short cables compared to the standards where you can run, for 1 gig, you can run much longer on most category standards. There may be some newer ones where they're getting better. I don't want to misspeak, but on the older standards, it was very limited range. Typically, you could do it in like a data center, but you couldn't really do it across a campus. One thing to note with these, they do not support PoE. So if you need PoE for your application, you need to buy a PoE switch or a PoE injector. You can put a PoE injector after this, but you can't have a PoE switch power something through this directly. And then in this case, I've got a SFP here. This is a multi-mode 850 nanometer Cisco SFP. And if we wanted to connect this maybe to 10 gig OM3 multi-mode fiber, we could just pop it in there. You'll see there's a little clip here. We can release that. Another note here, these actually can be reversed. So this is a crossover cable by default. But if you have a run in the wall, you have 2 crossover cables, one on each side, you're effectively having a straight through cable. So you may need to remove this little clip and switch the fibers around before plugging it in. Something to keep in mind. Now, if you were to go higher, like 40 or 100 gig, you may want to consider a different kind of fiber. This is OM5, which goes up to 100 gig. But you may consider OM4, which is a magenta color that would go up to 40 gig. I'm going to jump in here to my screen. So a few other things. I want to show you this DAC cable. I don't have a physical DAC cable. I wish I had one to show you, but I don't, so I just pulled this website. I'm not endorsing this website by any means. I'm not familiar. I just pulled it up off of Google here. So in this case, they're selling a Cisco branded. Now, in some cases, the SFP or the DAC cable will require it to be branded. So keep that in mind when you're going and buying these. You can't always just buy it right off the shelf. Some manufacturers are more lenient than others. So it's a standard. It should work in most cases, but be careful, especially if you're using some of the manufacturers that are a little more strict on what you can use with their equipment. And in some cases, you may not get support if you're leveraging third-party SFPs that might be, maybe a little cheaper. One thing to also note, in the past, I have dealt with some really, really cheap SFPs, and personally, I was disappointed in the quality. And when you get an SFP that you tried to save us a couple dollars on, stuck in a multi-$1,000 switch, it's very, very frustrating. So I stopped buying the really cheap SFPs myself. I went with more of a mid-grade SFP when I was on the customer side buying SFPs in bulk. So anyway, that cable removes the need to have fiber, and it removes the need to have these SFPs. So you'll typically see a DAC cable cost about as much as one SFP. You are effectively reducing your cost by half because you don't have to buy 2 SFPs. And then, fiber is not that expensive, but you'd have to buy fiber as well. So keep that in mind. But it's less flexible, right? We can't change the length of the cable. It's fixed. And we have to make sure we're ordering the right length. Whereas we can order a bunch of different lengths of fiber and figure out that later. DAC cables are also typically a little thicker. Some are worse than others. This one looks pretty thin. But I've had some DAC cables that were, just really thick cables that when you start doing cable management, they start becoming a pain in the butt. So when I was on the customer side in production, we were moving to all fiber. We were tired of the DAC cable issues with cable management in particular. Not any technical issues, just cable management really that we were concerned about there. So some of these 10 gig DAC cables also are going to work at 1 gig. So some of them may be where they work at both 1 and 10 gig. Look at the data sheet, make sure, but I would say usually that's the case that I would expect. I'm going to jump into the Fortinet transceiver data sheet just super quick to go over a few transceivers. I like the way Fortinet does it. It makes buying transceivers much easier. When I was on the customer side, I didn't have to worry about what model or, switch versus, firewall and other things. Or maybe different switch models had different SFPs. It really wasn't that complicated from the customer side. Now on the customer side, we only went up to 25 gig, so we were using that same slot. We weren't using any 40 gig SFPs, at least in my environment, and so we didn't have to deal with some of those different standards and some of the more complicated stuff. But I'll go over a few real quick here. So I'm going to skip this. This is a little bit of an outlier there. It's 100 meg. But a few of these, you'll notice this is 1000 base T, which is 1 gig. And you'll see here it's not exactly 1 gig. We refer to it as a 1 gig. Technically, it is 1.25 gigs. We refer to it in the industry as 1 gig. And you'll see it goes about 100 meters, which is a standard for Cat5, Cat6 Ethernet typically. It's going to be 100 meters or about 300 feet or so. This is copper, right? RJ45 connection. Now, when we go here to this SX stands for short range, and this is kind of confusing when I was first trying to dig into it because I see SX and I think single mode, right? That makes sense. No, it's multi-mode. Short range, multi-mode. We're talking 850 nanometers, which is going to be that cheaper SFP. Your multi-mode SFPs are going to be cheaper because the laser doesn't have to be as accurate because it's not going to be able to go as far anyway. And that's kind of like the standards there. So when you go to single mode, you're typically going to pay a little bit more, but it can go much further. You'll see that here in a second here. So it goes about 500 meters. You can see there's another one that goes 500 meters that has some different like detailed specs in it on the short range side. So you'll see, then there's a long range or LX. And you'll see it's the same speed, 1.25 gigabit, excuse me. But you'll see it goes 10 kilometers, right? That's much, much further than 500 meters. So, I like to think of the 850 nanometer SFP multi-mode. It's going to be going between buildings. It's going to go, in this case, what is that, 1,500 feet? Where in this case, it's going to go miles. Right? So when we're talking long distance, we're going to be using single mode. A lot of ISPs, they're going to be using single mode. Geographically dispersed locations that are doing a lot of dark fiber, maybe municipal governments, maybe counties. I saw it a lot with counties and school districts that are running their own fiber. Lots of single mode. So you'll see here that's 1310 nanometers. So that's going to be a smaller, more precise laser. So it's going to be more expensive. Going down here, we start seeing that all of these have SFP+. That means they're 10 gig instead of 1 gig. You'll see 10 gig base T. Base T is just copper, right? So copper interface, RJ45 connection. Now it requires Cat6A or better to get that 30 meters. Okay, so now we went from about 300 feet to about 90 feet. In terms of our distance, we can run 10 gig copper. Again, this makes sense in maybe a data center, maybe in a relatively short run. In most of our enterprises, we're not going to be using that short of cable. Again, keep in mind, if we're using one of these transceivers, we are not going to be able to run PoE either, which could also be a downside in an enterprise environment. Moving on, we have the short range, right? So we're going to have 850 nanometers. It's multi-mode. It's 10 gig because it has that SFP+. SFP plus long range. That's going to be our single mode. It's going to be a little more expensive, but it can go, again, miles, right? You'll notice these are all LC connections. So if maybe you didn't see the other video or you don't remember, this is going to be your LC connector. It's going to be a small connector. so that it can fit in this relatively small module. Going on down here a little bit, we've got some 25 gig transceivers. So 25 gig is becoming kind of the new standard as opposed to 10 gig. As our networks are growing and our traffic needs are expanding, 25 gig is becoming more and more popular. You see this SFP28, that's a 25 gig. You can see the technical speed, 25.78 gigs. But details. QSFPs are how we're going to get to that 40 gig speed. And then things are going to change a little bit. You see, we can still use LC connectors with these. These in particular are single mode. There's a multi-mode one here. And you'll see there's a different distance when you do OM3 and OM4. So if you recall, you can use OM3, which is this teal colored cable, but there's a magenta colored cable OM4 where you can really do longer distance on that 40 gig. And you'll see this is about 900 nanometers. And you'll see there's some different options here with the single mode transceiver. I'm going to skip some of these more advanced transceivers. I imagine if you're in this kind of market, you'll either know or you'll have a consultant that'll be able to help you with this. I'm not going to dig into that. But I want to talk a little bit about these direct attach cables. So you'll see here, in this case, it says up to 10 gigabits per second. So one of the things, and here it has 1 gig to 10 gig per second. So one of the things about fiber is fiber doesn't negotiate the same way copper does. Copper, we can negotiate speeds. There's protocols built in that allow us to do that negotiation. It's not the case in fiber. So fiber is not going to be able to have those speeds negotiated. It's set on the transceiver. Whereas copper may be able to negotiate those standards. So keep that in mind. These passive cables are going to be able to go either 1 gig or 10 gig typically in most applications. That way you can buy one cable, and if today you're running 1 gig and later you're upgrading to 10 gig, it's no problem. You can use the same DAC cables. But they're going to come in lots of different lengths here. You'll see, up to 10 meters. A meter being roughly 3 feet, 3 feet up to 30 feet here in the US. You have some different options there. But they're directly going to attach to these SFP or SFP plus ports, switches, firewalls, etc. And you'll see here there's also some QSFP DAC cables. Now, when I talk to peers in the industry about QSFP, a lot of times it's really, really expensive to get those optics. So I usually position QSFP DAC cables as a major cost-saving mechanism, if at all possible. But in some cases, you may prefer just using some fiber like the good old days. So I hope this video has been informative for you, and I hope it's helped you wrap your head a little bit around maybe some direct attached copper, SFP, and fiber concepts. And if you have any questions, feel free to reach out, and I'm happy to help. Thanks for watching, and have a great day.